Hi, Geometry Advanced kiddos. We are actually going to do another lesson that helps prepare us for pre-calculus based off of using what's called the law of sines and the law of cosines. And you'll use these on a fairly regular basis. And we're first going to talk about the law of sines, and we're going to see how it's actually derived. Now, all of this that I'm going to show you is stated in this paragraph, but we are going to actually have to use a concept that we can use sine, cosine, and tangent with angles bigger than 89.9999 degrees. So we can actually use this with obtuse angles too. But again, your calculator has all that in a chart. I'll let you get into the why of that later in pre-calculus. But I want to be able to set up a proportion that can help me solve for the length of the sides. So first of all, I'm going to let this angle be the angle I'm working with, and I want to solve for h. So what would be the ratio that I'd use with h and b? I'd use the sine. I'd go, all right, the sine of angle A equals opposite leg over hypotenuse. So if I'm solving for h, I get b times the sine of A, okay? Now if I do the same thing that I'm solving here for this angle B, I'm going to do the same thing. This ends up being my opposite leg. This ends up being my hypotenuse. I go sine of angle B is equal to opposite over hypotenuse, but that's A. Again, I solve for it. I get A times the sine of B equals H. And then I know that those two are equal to each other because they're both equal to the same thing. So I go B sine of A equals A sine of B. Now, that's obvious because I can substitute one in for the other. What changes is actually I want to change how it looks. So all I'm doing is using the properties of proportions that I know. And I'm going to divide both sides by A and B. As long as I do it to both sides, it's okay. When I do that, the B's cancel out, and I get the sine of angle A is to A as the sine of angle B is to B. I get that ratio. And so the cool thing is I can actually do that with the sine of angle C too. We're not going to go into the details for that right now, but it can work doing the same type of idea. So I just want to reiterate, this is from the right triangle on left, and this is from the right triangle on the right. And that actually sets up our property for the law of sines. So let's flip this over. I would like to do this in like 2 videos here. So first of all, our video for this one is going to be the sine of A is to A as the sine of angle B is to B, and the sine of angle C is to C. Now please notice where the C's come from. The angle and the side that are opposite each other have the same letter. So my capital C is for the angle because that's a point, right? And then I have the side opposite that. So that's where you get the values coming together. So obviously notice A and A are opposite of each other. And notice that angle B and side B are opposite of each other. And we can use those to solve for missing sides. In fact, you'll do this in pre-calculus. But you can only use them for certain scenarios and what you're looking for. You can use the law of sine when you know 2 things: 2 angle measures and any side length. So you can use it for angle, side, angle, or angle, angle, side. So actually using that terminology will help us figure that out. Or you can use it when you have 2 side lengths and a non-including angle. Now this is the first time that we actually let you use side, side, angle, because normally it's just with the hypotenuse leg. So all those scenarios work. And in fact, I was just talking to Miss Hanson, and they just talked about this in pre-calculus the other day. So looking at this one, I want to know the length of segment FG. It's right here. This is the segment I want. I don't know it, but do you notice that I have an angle, and a side? All right? And so I can actually do this because of my proportions. Now, the cool thing is you normally only have to set up 2 values for your proportion because I'm not going to set 3 ratios equal. So I'm going to do the following. The sine of A is to A as the sine of angle B is to B. Now, doing this, what do I mean by angle A and angle B? Well, you just pick one of the angles you're going to work with. So I'm going to let this angle be angle A. So I'm going to go the sine of, and I'm going to do this in red, okay, of 32 degrees is 2 to the side that's opposite. There's your segment FG. So we have it there. Is the same, I'm going to do this one in black. This is my angle B, as the sine of 39 degrees is 2 to the side opposite that, 40. So notice I have only one piece of missing information. So now I'm going to take the time and I'm going to solve for length of segment FG. I'm going to first cross multiply. So length of segment FG times the sine of 39 degrees equals 40 times the sine of 32 degrees. Now I want to get FG by itself. So I divide by the sine of 39 degrees. So the cool thing is I know the length of segment FG, okay, is going to be 40 divided by the sine of 32 degrees. Oh, excuse me, 40 times, I'm sorry, my voice is killing me here, times the sine of 32 degrees all over the sine of 39 degrees. So then you just have to punch it into your calculator. And if we're doing sides, let's just go to the nearest tenth right now because we're going to get a lot of complicated values. So the length of segment FG is going to end up being 33.7. And so that is the length of our segment. All that work for one simple little thing, but I promise it's very doable when we work with this one. So now let's look at B. This time I want to know the measure of angle Q. So let's just call this one X degrees to make it easier on ourselves. I don't know that angle, but notice what I have here. I have a side, and an angle. So I know I can still set up my law of sines because I'm going to work with two angles, I'm going to work with two sides. Well, I do know that this angle and that side are opposite of each other. So I'm still going to use my proportion. Sine of A is to A as sine of angle B is to B. Now A, I'm going to let these be the ones that go. So I got the sine of 51 degrees over 8 is the same as, I don't know this angle, so that's the sine of X degrees as 6, because those are the ones that are opposite. You guys see how they're opposite of each other? Because remember, opposite angle and side are where we set up in these proportions. So now I go ahead and I cross multiply once again. Or actually, we can make this a lot easier. Instead of cross multiplying, how about if we just get sine of X by itself? So we're going to multiply both sides by 6. And actually, I'm going to change this around just a little. I was going to say I was going to change it a little bit, but yeah, I think I'm going to. I'm going to go the sine of X degrees is equal to 6 times the sine of 51 degrees all over 8. Now, remember, I'm looking for the angle. So how do I find the angle when I have a sine ratio? Yeah, I use our inverse. So I go my inverse sine of this whole thing. This is when you have to be good at what you calculate on your calculator. So when you have that, you punch it in, and it's going to the nearest degree. You should get that to be about 36 degrees. Now, if you're not getting that, that's probably more how you're punching it into your calculator, but you are going to have to show me all those steps. All right, let's try another one that we're working with. All right. Now, on this one, what do we have? We have a side angle again. So this is doing our last value that we have up here. So we're going to be solving for the missing angle like we just did on the last one. So I'm going to let this be my X degrees because I think this is a little bit harder to solve for. Now, with this one again, I'm going to set these up to go with the sides. So I'm going to let this be, all right, my sine of A over the sine of B. And I'm just going to do this real quick, and I'm going to have to work sideways, which I don't like doing. You guys know that. But we're going to do this. We're going to get the sine of X degrees is to 4.3 as those two go with each other. The sine of 50 degrees is to 7.6. Now I want to get the sine of X by itself. So I'm going to multiply both sides by 4.3. So I get the sine of X degrees equals 4.3 times the sine of 50 degrees all over 7.6. What did I do? I multiplied both sides by 4.3. Then I have to use my arc sine or my inverse sine to find the value of the angle. So we go sine inverse of the whole thing. So we go the inverse sine of 4.3 times the sine of 50 degrees over 7.6 equals our x degrees. So our angle to the nearest degree is going to be 26 degrees. All right. Now, because I just want to make sure we have all this on the same page, we're going to do C yet when we're working with it, because I want to make sure that we know how to use this one. And looking at this value, we are given angle, angle, sine. Okay, so when we have angle, angle, sine, what we're going to do is again use the sine ratio. But again, these two are opposite of each other, and these two sides are opposite each other. So why don't we call NPX this time, just so it's going to be easier for you to solve. So I go again, the sine of angle A is to A, as the sine of angle B is to B. Alright, so A, I'm going to let be, it really doesn't matter which one you really let to be. Let's go 88. So the sine of 88 degrees over X, because those are the opposite angle and side, is the same thing as the sine of 39 degrees over 22, because those are the opposite angle and side. So I cross multiply. I get X times the sine of 39 degrees equals 22 times the sine of 88 degrees. I'm going to divide both sides by the sine of 39 degrees. Once you do that, this is what you plug in to your calculator. Just be very careful with your parentheses. When you do that to the nearest tenth, give me a moment here because I need to get a punch that to my calculator earlier. Let's make sure we have it on. Alright, we get 22, the sine of 88, parenthesis, divided by the sine of 39. And what do we get? 34.9. Alright, I will record the rest of this video working with the law of cosines in just a little bit.